Thank you very much for the wish, and let me also join everyone and wish you Happy New Year. Happy 2021. Let's hope for 2021 to be almost as good as 2019. Ladies and gentlemen, welcome to the first Epic Online Technology Meeting of 2021. Hello again. We may have been quiet over Christmas, but on Monday, January 11th, 2021, we switched the lights back on to fire up Season 3 of the Epic Online Technology Meetings. We are lining up over 25 in-depth discussions to take us up to Easter and beyond. We are bringing together FNCW LIDAR companies like Scantinel, enablers of 3D sensing like the giant Lumentum, optical FPGAs and optical processors like Ipronics or Xanadu. We expect insights on agri-tech from one planet and expect the unexpected from Intel, exploring new applications of integrated photonics well beyond datacom transceivers. And how about photonic sensors produced in volume for the Internet of Things? So join us Monday, January 11th, 2021 for a top-level discussion on what's next for photonic integrated circuits, including short-term prospects for business. Sign up to participate in our Zoom room or watch it in real time or anytime on our YouTube channel. You'll definitely want to follow up on this one. I hope all of you had Christmas time and collected as much energy as I did. So I drank a lot of coffee over Christmas to have enough until Easter. We are ready to start this season of the Epic Online Technology Meeting. So we want to start with a topic that really touches all in the heart, because both Anna and me have a background on photonic integration, and with this we would really want to engage more of our members into this huge boom that photonic integration is living in this decade and last decade especially. With this, I would like to say that Epic keeps growing. We have passed already 650 members. If you see value of being a member of Epic, please let us know. If you're wondering what we are, contact me and I will be more than happy to have a chat with you, because we want this number to even grow even further than 650. As I said in the video, this is the season 3 of the Epic Online Technology Meetings. We started back in April as a solution for the COVID-19. We never realized the huge impact that these meetings were going to have in the industry. So we're going to continue them. We're going to be soon all vaccinated and continue having our online meetings. There's a huge value in connecting people while they are working from the comfort of their own desk. At the same time, I would like to say that these are the online meetings for Q1 2021. I tried to select topics to make sure that at least there is one online meeting suitable for every Epic member. For most of you, at least 5 to 10 meetings are suitable. Register online as soon as possible. Many of you are wondering why your logo is not in the supply chain of the meeting, because you didn't register. Register online for these meetings as soon as possible. And remember also that in 2021, we are making an extra chapter for the quantum technologies. On the 12th of February, we start also with our separate online quantum technology meetings, in which we're going to bring the top quantum researchers and the industrial end users to define a roadmap for every application field in quantum technology. So please register online for these meetings if you are interested in this topic, or most important, if you see business for your company on this topic. I also would like to wish Happy New Year from my fellow Epic team. We have really keep growing. Actually, we have a person to be announced this week is going to be hired for the market reports. Epic wishes you Happy New Year. And that's all. Let's talk about photonic integrated circuits. And with this, I would like first of all to acknowledge our media partners, Electro Optics, ASO Optics, and Photonics Views. Thank you very much for promoting these events, but also for documenting the result of these events in your fantastic magazines and online websites. Thank you very much for this. And also today we have a very good list of sponsors. This meeting would not be possible without the support of VLC Photonics, all the way from Valencia, offering design services and access to each part of the supply chain. They actually develop their own building blocks and they can test them because it's also a testing house. All the way from the Netherlands, PHIX. PHIX is a company that has experience in packaging a broad range of materials, including silicon, silicon nitride, silicon insulator, indium phosphide, gallium arsenide, lithium niobide, polymers, and many, many more for applications that go from quantum to biosensing and, of course, communications and LIDAR, all the way from Belgium, Luceda Photonics, a company that I personally love. These guys provide photonic IC design, software, and support. The Luceda's PICs photonic design platform, Python-based, is one of the ones of choice to implement all the PDKs from the different foundries in this world. PI all the way from Germany if you want accuracy, if you want a system that can actually be stable, if you want stages and hexapods that can actually package silicon photonics. PI is the great company for the alignment and motion tools of every optical setup. Modulight all the way from Finland, they manufacture semiconductor lasers. Actually, they provide their own wafer growth, actually MBE, all the way to making devices that go even to clinicians. For every application field, you're looking for a 1.3 micrometer wavelength laser, and any wavelength that goes from the 1.1 micron to the 2 microns, Modulight is the way to go. Vigo Ventures. Vigo Ventures from Poland have been investing in many, many EPIC members. If you are looking to raise capital, talk to Vigo Ventures, one of the investors that we have in EPIC. But if we go to Obducat in Sweden, Obducat is a company that makes equipment for the volume production of any optoelectronic device. From the nano imprint to the raw manufacturing, Obducat, a partner of choice. And I would like to finish with a company we all know and love, Besi. When it comes to the volume production of any optoelectronic device, and even to the assembly of laser diodes into any substrate, you are looking for a partner that is called Besi, can provide you with the R&D, but also with the fantastic equipment for the volume production of optoelectronics. Thank you very much, my sponsors today. And with this, I would like to give the floor to the EPIC expert on photonic integration and R&D manager, Dr. Ana Gonzalez, on the way from beautiful Barcelona. Ana, what's in the menu today?
Thank you, Jose, for this introduction, and hello, everyone. I'm very happy to start the year talking about photonic integrated circuits. As you can see today, we are going to talk about emerging applications using PICs, such as LIDAR, quantum computing, agri-food, and structural monitoring. And regarding companies that are attending and are ready to participate into the discussion, well, thank you for registering. The supply chain today is very, very complete. At EPIC meetings, we want to take into account the needs and challenges of end users of the technology. So today we have a great list of end users in the room, such as Continental, Facebook, Samsung, Bosch, Electrolux, Huawei. Then we have all the companies that are doing PIC modules, companies doing lithography tools, software, all the equipment, associations and photonic technology platforms, the R&D. And finally, I would like to mention the projects in which we participate. For example, the Passion project, which aims to develop a new architecture approach for metro network by developing a new kind of transceiver, integrating silicon photonics and VCSELs. Then we have the pilot lines, which are together developing a standardized process. For example, JPIC's pilot line, which offers large volume manufacturing of indium phosphide photonic integrated circuits, but also PICSAP pilot line, which offers packaging and assembly of these chips. Also very linked to the supply chain for PICs, we have Fabulous, that is for manufacturing high volume of freeform micro-optics. And more related to applications, we have MIRFAB for prototyping and going to large volumes of mid-infrared sensors, but also MedFab, that is the pilot line for fabricating medical devices. And I would like to make a special announcement today. Starting this year, we have a new initiative that will bring photonics to new companies and new businesses. This initiative is Photon Hub. Photon Hub will support users around Europe that are not experts in photonics to increase the TRL of their new products that are based on photonics before to make a big investment. So if you are interested in this new initiative, please contact us. And that is all, Jose. Thank you.
An applause for Ana that was working over Christmas to make sure that the key companies in Integrated Photonics will be here on the 11th of January. Ana, feliz año nuevo. Happy New Year. I would like to also remind everyone in YouTube, also YouTubers, Happy New Year. I would like to remind that this meeting is live is broadcasted live in YouTube. If you want to get in touch with any of the participants, my YouTubers, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will be more than happy to make the introduction. But also feel free to use the chat at the YouTube channel. Any question that you write there, I will read into the room. This is also valid for the people in the Zoom room. During the meeting, you can use the internal chat here in the Zoom channel. Please make sure that you use it and you get in touch with each other. After the meeting, you can also contact me, and I will be more than happy to make any one-on-one introduction to any of the fellow participants that were here in the meeting with you. And that is all for the introduction. It has been really, really great to tell you that we keep the energy momentum of 2020. And now I would like to give the floor to Ana Gonzalez so she can do me the favor of introducing the first speaker today.
Yes, for sure. So the first speaker is going to be David Cheskis from Lumentum, and we are going to hear about LIDAR. So hello, David. Would you like to share your screen? Yes, first of all, you are mute.
There we go. Hello.
Very good.
Good afternoon, and thank you for having me today. I'm excited to be here and start the new year off this way. Happy New Year to everybody. And can you see my share now?
Yes, very good. If you can go to presentation mode, that's it.
I shall. And Anna, thank you. And Jose, Happy New Year to both of you. And like I said, happy to see everybody here. It feels like it's February already, but doing so much work since the beginning of the year. But I'm going to spend a little bit of time today to talk about the VXL PIC solutions for automotive LiDAR applications. And so, LiDAR is an interesting and exciting topic, and VXLs have been a good solution for that. And there's new applications that we can go and do with putting VXLs together as a PIC. So I'm going to walk through that a little bit. But first, I want to talk, just so everybody knows who we are, Lumentum obviously is one of the world's largest laser companies out there. We've got over $1 billion, close to $2 billion in annual revenue. And we are the world leader in 3D sensing diodes. And, we do a lot of different diodes, laser technologies throughout the world with over 5,000 employees and established high volume manufacturing infrastructure. And that's really the key to enabling this. And let me go and talk a little bit about what 3D sensing is here. Oops, sorry. Let me go back for a second. So really, 3D sensing, people have been talking about it as recent applications, exciting going on. But it's been going on for many, many years, actually. I mean, we've been doing it for close to 10 years now. You can kind of see the timeline here of how we've been approaching it all the way back since 2010 in gaming applications with edge emitting lasers. And around 2016-17, we started to service the 3D sensing mobile market with VXLs. And you can kind of see that rudimentary array that we've got of a VXL there in the timeline used for the mobile front-facing biometrics. And started to evolve that technology. And today you can kind of see what we've evolved into is really multi-junction VXLs and addressable arrays that really turn this into much, much more of an exciting PIC technology for things like world-facing AR, cabin monitoring, the consumer LiDAR, autonomous vehicles, and other types of applications there. So I wanted to spend some time talking about these new technologies, the multi-junction VXL and addressable arrays, and how that really impacts what we're going to be doing in the space of LiDAR today. First, let me talk a little bit about what these product offerings look like. Today we've got a wide suite of these existing arrays that go all the way from a couple watts all the way up to 5 watts. That really what are intended to do is extend the distance of the illumination source here. They're all typically around 940 nanometers. They're different sizes, different shapes, and they do different things. But basically, they're really designed to be time-of-flight light sources for flash systems, and really designed to just provide more power in the right way, in the right manner. And what we started to do was we started to take this and take another dimension to this and add more things to it, which is multi-junctions, increasing the power levels that we can reach, which actually, as you can see there, increases the distance that you can use these from 1 meter, 3 meters, 5 meters, and beyond. So for automotive LiDAR, we really need to get to much, much higher power levels, higher junction numbers in order to service those markets. And then also addressability, so we can do new things with these types of products. And what does the automotive market provide for challenges for us? You can see the top three things on the left-hand side there: the resolution, brightness, and range, eye safety, and ruggedness, no moving parts. And really, from the LIDAR illuminator, the VCSEL, we need the highest power, as we're talking about, high speed, and the ability to integrate the sensors. And that's what we get out of these multi-junction addressable arrays, and new integrated optics that will allow us to do beam steering, other kinds of beam quality measurements in order to be able to, again, map up to these new applications. Again, LIDAR is not new itself. It started with just very, very high power lasers and trying to get as long a distance as possible. And now we're starting to the point where we're getting higher power and more addressability and more interesting types of integrated circuit capabilities out of this. So briefly, one of the things that we've been working on is these multi-junction VCSEL arrays. The more junctions that we've got, the more photons that come out with the same type of overall wall plug efficiency that we can improve then from there. So the lower currents that we are typically using in 2-junction, 3-junction allow us to get higher levels of power, faster applications. You can kind of see short power bursts, a few nanosecond pulse widths, and we can get hundreds of watts of power from chips that are just a millimeter on a side. So that's a real exciting new application, a new technology that we brought into the market there. And then this addressable matrix that we've got now that we have new manufacturing capabilities, and again, we've been manufacturing these VCSELs for about the last 4 or 5 years, we're now able to start improving how we address them. And rather than just turning them on and off all at the same time, we're able to do these addressable arrays, and we do them in 2 different formats. One is this 1D addressable array you can kind of see on the left side there. And then the second would be a matrix addressable array on the right-hand side there, where we can pick and choose which parts of the subarray you can light up at one time. And you can do this to, again, match up with what your detector requirements are. In this case, for SPAD detectors, for LIDAR, you can make it look like a linear array. In a 1D addressable array, you can make it look at multiple region of interest and focus points with a 2D matrix array. And that's what's really enabling the next generation of LIDAR technologies to go and really improve their systems to do the things that they need to do, which are focus on longer distance, higher resolution. And this does it all with the same system and improves optimizes the cost and performance. And then finally, one of the really exciting things that we're doing now with these PICs is to actually start to do bottom emitting devices, which allow you to make devices with no external optics and really modify what the beam profile looks like coming out. And we're able to do that by putting these external lenses on the back of the device. You take your chip and you flip it upside down, like you can see on the left-hand side there, and mount it top down onto the submount. And then you can pattern the gallium arsenide, and it allows you to do new things with the output pattern you can see on the right-hand side there. You can modify what that looks like. You can then take this and integrate all of these things together in terms of multi-junctions, addressable arrays, and optics to create new and novel patterns. And you can kind of see on the right-hand side there, you can do 1/2 at a time. You can do all kinds of different patterns there on the bottom right, which is 8 sections looking like that. And so that's really the culmination of all of these different integrated circuit capabilities into LIDAR VCSEL chip applications. And then again, you need to put it all together with reliability, and that's important for LIDAR in the automotive industry. And we've got all that stuff taken care of. So it's a really exciting time to be in the industry here. A lot of innovation. And we've got the latest generation of high power multi-junction VCSEL chips for time of flight LIDAR architectures. Again, addressability. And the VCSEL development has advanced rapidly in these high volume applications with a really, really amazing manufacturing infrastructure. And we're focused on expanding our automotive portfolio. And key to making that successful is engaging with our ecosystem partners and people like yourselves in the audience here who have a lot of great ideas and a lot of great technology, and looking forward to talking with all of you about how we can move forward from here today. So thanks very much.
Thank you very much, David. 1 second, I'm going to stop. Okay, so now you know what is the question that I'm going to ask. What kind of challenges do you have? What kind of technology challenges would you like to present to the supply chain that is here attending? How can we help you in the packaging or in the fabrication of the pixels?
Yeah, absolutely. I think the packaging is critical to this. Doing these VCSELs with these kinds of technologies. So now we've moved upon beyond what we had for just initial VCSELs and just packaging them in a plastic package and shining lights and going from there. Now we've got to improve how the packages work, what kind of speed we can get from the packages, how much connectivity we can get from the packages, and then really how we can utilize all of these capabilities we're building the chip. So I'm really excited about talking to people about novel packaging technologies and way to go and do these things, but also testing capabilities, because testing of these devices is a very, very challenging requirement. Now you're not just testing a laser at one time, turn it on, turn it off. You're testing multiple sections. You're testing the different sides, upside down, back, forward. You want to look at the near field and far field. So testing becomes extremely, extremely complex, and that's exactly what we're working on facing these days is packaging and testing.
Okay, then we have packaging and testing. Okay, so for the companies attending, if any of you think that can help David, Lumentum, with the packaging and testing, please contact us and we will help you to contact with him. And in the meantime, we got a lot of questions in our chat. So, yes, from Soitec. Sorry, I cannot see the name. From Soitec, do you want to make the question from yourself?
Let's see.
Corrado from Soitec.
Yeah, please. Hi, David. How are you? So it's Corrado from Soitec.
Good afternoon.
So you thank you for your presentation. One question regarding multi-junction VCSEL for higher power levels. Have you assessed the lifetime and the reliability of this multi-junction VCSEL array, especially for consumer market requirement?
Yes. Look, we have been working on these for years. We're evolving them right now. So we did 2-junction, 3-junction, we're up to 5-junction VCSEL technology right now, and you're right. It's critical to ensure that they perform. But what we have to do in that case is we have to modify the VCSEL epi structure in order to be able to get the performance and reliability with that. So it's critical, but we're able to do that with some cool new advances.
Thank you, impressive.
Yeah.
Okay, and then we also have a question from Milan, right? From the University of Southampton. Can you want to ask the question first?
Yes. Hello, David. Thank you very much for a very interesting talk. So you mentioned, you listed several requirements for making LIDAR commercially available, and you talked a little bit about packaging and testing and so on. So in your opinion, which one of these is the most critical one in terms of requirement?
Eye safety.
Eye safety. Okay.
Yeah. So, which is a combination of a bunch of different things, right? So it's power, it's wavelength, it's operating speed. But LIDAR specifically, now automotive LIDAR is also eye safety and reliability. So all of these things go into being able to figure out, what kind of laser can you use, what kind of technology do you need, what kind of system can you design in order to detect an object far enough out there to be able to guide vehicles autonomously, but also be safe. And that's the most important thing in LIDAR is safety.
Thank you.
Okay, thank you. Then we have also a question from Eneka. Eneka, would you like to make the question by yourself?
Yes, hello, I'm Eneka Yarbarsum. I was a private former partner with Valeo, so I know a little bit the automotive market. Can you develop, please, about what you mean by extending automotive LIDAR applications? Because you mentioned, I think, the time of flight.
Mm-hmm.
But can you please tell us a little bit where is going the automotive market in LiDAR at the moment?
Oh yeah, sure. Look, I think when you look at the LiDAR market today, it's broken down into many segments. And what we're able to accomplish today at the right price points with the right performance is really a shorter range, a LiDAR system, 100 meters, maybe 150 meters. The goal is to get that obviously to 200 to 300 meters in order to enable full autonomous driving at highway speeds. That's again required to make sure that we're safe. Those are the same applications, but it's just, I think the laser technology is enabling it. The LiDAR technology itself is increasing there in performance. But what you also have to remember is that LiDAR is only one component of the autonomous vehicle system. You've got many other sensors that go into making up what this, how a car perceives its environment and how it drives and guides itself autonomously. So you're going to have LiDAR, you're going to have radar, you're going to have cameras, you're going to have a bunch of different sensors, and integration of all of those is what's key to making that happen.
Excuse me, so it's exactly what you mean when you mean extending your capacity. It means that you are working on integration of several types of sensors. Not only
what we're doing is we're enabling these lasers to give you the performance that's needed in the LiDAR market to do the things they're trying to do today. So what they're trying to do today, they're working and they're improving, but in order to be able to give them better performance, better tools in the LiDAR sensor space, we're giving them the higher power with the multi-junction. We're giving them the addressability in order to be able to optimize the way they cover that space. So it's really solving the problems that they have today by providing them with these new technology capabilities.
And just another question: Are you as well, when you think about eye safety, it means that you are going to change of wavelengths?
Yeah, well, so that's a great question. Another one of the questions in here is what is the optimal wavelength for LiDAR applications? I've been asking that question for about 5 years now, and I don't think there's an answer for that yet. Sorry?
I know they do not know.
Well, you know what? I don't think there isn't one answer to the question. I think there's short range LiDARs that will have one power level requirement, and you can operate at a certain wavelength. At that power level, which obviously you can work in the below 1 micron space there. Longer wavelengths, you probably want to work at a higher power level in order to be able to again maintain eye safety and recognize these objects out there. But again, it's a much more complex discussion, because if you look at the costs required with different sensors at shorter wavelengths below a micron or so, you can use a silicon-based sensor. At a longer wavelength, you can use a much more expensive indium phosphide-based sensor, InGaAs sensors. There's cost, there's performance, there's eye safety. And again, I kind of always like to think about it as this is not a problem that's solved in automotive LiDAR by one particular component. One LiDAR, one laser is not going to fix this. One SPAD is not going to fix this. It's all of these together, and it's how do we provide an environment that can be used to understand your scene. So it's going to be a combination of all these different technologies, which again is still evolving, but I think that you'll see they'll come together to the point where you've got several different sensors doing multiple different things. And I think in particular, LiDAR in the automotive space is going to find not just one place there, but multiple places in a vehicle. It's going to be a long range LiDAR. There's going to be short range LiDARs. There's going to be LiDARs around the vehicle, doing different things and making sure that we're doing this safely. And what that means is it's going to be much lower cost. It's going to be, you're going to have to implement these kinds of features that we're talking about, addressability and higher power levels. And it's going to be something that you're going to need to scale up very, very dramatically in order to meet these demands, because it's not just one, it's going to be multiple ways to do it.
Okay, so thank you very much, David. We still have some questions in the chat, but we are going to move. Next presentation is also about LiDAR, so we will keep these questions for after next presentation. We have an important end user here in the automotive industry. I don't know, Heiko from Continental, are you here?
I am here, yes. Hello.
Hello, Heiko. How are you doing?
I'm good, thank you.
Happy New Year, and thank you very much for joining today. And do you have any comment about the applications, about what do you think will be, what is your vision about the future of photonic integrated circuits in LIDAR? Do you want to make any comment?
Well, first, David is completely right in saying that there's not just one application in automotive where LiDAR can be integrated or can be useful. There's plenty of applications, and as he said, long range, short range, kind of surround view, maybe even maneuvering application that don't need much range, and there's indoor applications as well, both for occupant health, but also for augmented reality. You have probably heard about these 3D displays like the one that Leia is doing. In these displays, you need to know especially the position of the person who watches the display as well. And there also LiDAR can do a great job in locating the viewing position of the person who uses the display, and this application obviously has totally different requirements than the one for long range, identifying a small object in 200-meter, 250-meter distance. Completely different systems, completely different applications. So there's not this one thing, but with respect to photonic integrated circuits, of course, the integration is of great interest for the automotive industry. That promises reduction in size, that promises reduction in cost. Maybe not today, but in the long run, right? Even car makers from the premium segment, they have a hard time integrating LiDAR sensors today, which cost probably €1,000 each and more, much more sometimes. And this is just, there is no business case on the long run. There is today because it's a hype and everybody wants this and everybody wants to see LiDAR in the cars. So there is, so the bar is lowered, not really by the economics, but by the hype of the technology. This changes. This will change in the future, and products need to become more cost-effective and more volume effective. And I think that the integration aspect of photonic integration is the key here.
Okay, thank you very much, Heiko, for your vision and your comments. So keep attention, I mean, pay attention for the next talk that is going to be from Davide Canavesi from Scantinel, because they are also doing LiDAR using photonic integrated circuits. So yes, Davide, if you want to share your screen.
Yeah, thank you, Anna, for the warm welcome, and yeah, hi everybody. Happy New Year. I'm trying to share my screen. Just let me know if you see it popping up.
Not yet.
Okay.
If not, maybe we can. Okay, now.
As you.
Mm-hmm.
Is it there?
Yes, it's there. We can see it. You can start.
Okay, so so happy New Year to everybody. Thank you for having me here. It's a pleasure to bring FMCW to the talk. Thanks, David, for your presentation. And thank you, Heiko, for your comment on LiDAR. It's super interesting to talk about all those topics. Still, there's a lot of things moving on, and it's my pleasure to add our view on this discussion. So. My name is Davide Canavesi. I'm working as business development manager for Scantinel Photonics. Did you see the slide changing, for instance? Or still freezed on the first one?
No, no.
Okay, so it's just slow. You just need to take into account. So a brief introduction of Scantinel. We are a spin-out of Zeiss based in Ulm, Germany, and we focus on FMCW LiDAR, so coherent ranging. I now moved on to the next slide. If you can just give me, yeah, do you see it? Just give me a go.
Now. So if you want, you
Yeah,
can
good.
start talking, and then we will see the change. Don't worry.
Yes. And so as we were already talking before, we are also facing the same ABC challenge of everybody working on sensors for autonomous mobility. And so people are expected from us to deliver a LIDAR system that will augment the perception capabilities of the vehicle or of the system where it will be mounted on. And this means that we have to deliver something that has more performance as the systems that are out there nowadays. This should enable new business model or new applications that will find their place in the market. And see, this has to come with a very cost-effective solution. So let me then go through and present what's the approach of Scantinel in these terms, which are the benefits that our approach are bringing, and then which is our take on collaboration. So our approach is, as said, to use coherent FMCW ranging to achieve longer distance. And then to get to this long distance, we are using a 1550 nanometer integrated swept source with a narrow bandwidth and high linearity. This is a key requirement for FMCW. And then we leverage the combination of photonic integrated chip and optical collimator for the scanning of the LiDAR. So this is what we call optical enhanced array, OEA. And we really believe that silicon photonics, bringing the high integration of the system, is the key technology to enable a full solid state solution that can scale up into high volume and therefore bringing to a very competitive price points. And then to achieve a high megapixel per second data rate that is required, we use a high parallelization of different FMCW channels. So which are the benefits that this approach brings to the final LiDAR product? Well, the optical enhanced array provides low power and fully solid state scanning solution. Then with this approach, we can achieve a longer range in the range of 300 meters, as David was saying before. That's kind of the next generation requirement. And this is driven by a higher sensitivity of the system. We provide a 5-point cloud at more than 2 megapixels per second, where you can have the information of direct velocity in every pixel. And this is kind of a very important aspect that can enable the detection and prediction of narrow object at far distance. And last but not least, all the design is done to achieve high volume manufacturability to bring a very competitive price point. So we at Scantinel, we believe that collaboration is essential in this game. And we are so happy to be part of the APIC Association. We have already 2 ongoing collaborations with partners of the APIC Association, IMEC and PHIX, with whom we are working on solid state, beam steering, and integrated long coherence length tunable lasers. And with PHIX, we are working on packaging already. So, since I know the coming question from you, Anna, I did prepared a little like list, shopping list. So we are very welcoming and looking for collaborations in the following areas: micro isolators, either chip scale or micro optical components. Then we are looking for technologies to have semiconductor optical amplifiers, 2 4 watt output power with high efficiency. and then advanced assembly technologies for those micro-optical components, and also maybe, if possible, if someone is already working on this, on low power 1550 nanometer switches with a small footprint in CMOS compatible technologies. Having said this, I thank you, and I'm open for questions.
Thank you very much, Davide. Grazie mille and Happy New Year. Happy New Year, Davide. I love that you come always with this fantastic shopping list, and I also love that you follow up in all the introductions that we made for you. So I hope you keep working with the EPIC members. I'm gonna start already with the questions because there's many for you. The first one comes all the way from Switzerland. Amir from CSEM, what's on your mind?
Hello, David. Can you hear me? I don't know if you can hear me. Yes. So actually, I have a quick question, two-part question. First, you mentioned this, the high volume thing, and then you said you would get this cost bracket high volume. What do you mean by high volume? What can you quantify it? Is tens of thousands, hundreds of thousands, or millions? And the second is what can you also comment on the logic of why you think the silicon photonic is the future? Is just the scalability and the available manufacturing, or is there certain building blocks that you cannot find in other platforms? So what is it, more technical or more business?
Yeah, thank you for the questions. It's actually a combination of the two, and they are really interlocked. We are selecting technologies that are CMOS compatible only. So the idea behind is that having all CMOS compatible technologies, we can leverage the high volume manufacturability of CMOS, and in this way we think we could achieve a very low price point. So, and for sure, if you look at the numbers, so high volume is really million. That's what is promised, but it's always the question is, as always, it's a complex equation, because it's not just that you have to provide the right sensor, but you have to build such a system that will enable a business model or a new application that will ramp up. So it's all the stakeholders have to make it happen.
Thank you very much, Amir, and I hope you are progressing with your lithium niobate foundry, thin layer lithium niobate foundry that Amir is putting in place, looking for partners. So you want to be playing a part on this, contact Amir. Good job on that, Amir. I would like Davide to give the floor to the next question, and this one comes from the most active EPIC member, from Huawei. Benete Troya, Happy New Year. What's on your mind?
Happy New Year, Jose. Thank you, Davide, for the nice presentation. I've actually a couple of questions about the level of maturity of the co-integration of electronics and photonics. For coherent FMCW LIDAR is critical. You mentioned, for example, the polarization of the emitters and also the capabilities of steering the beam to achieve the automotive grade requirements. So for the success of your products, how critical is the level of maturity of the co-packaging of electronics and photonics? Thank you.
Yeah, so thanks for the question. It's definitely something really, really crucial. I can tell you we have taped out our chip already last year, so we will be able to get them, I hope, if everything goes well, by the end of the month. So in terms of beam steering, we will be able to demonstrate a 1D and 2D solid state steering using the combination of silicon photonics and optical collimator, I think within this year. And then in terms of laser integration, we are also progressing quite well. So tape out is this month. But yeah, definitely when it have to come into a product, the maturity is quite essential. Yeah.
Let's go now to our next question. It goes from Keysight. Marcel, Happy New Year. What's on your mind?
Hi everyone. Thanks, Jose. Happy New Year too. Davide, I was wondering, you mentioned your measure 5 parameters, the XYZ, velocity, and reflectivity. what is the reflectivity used for in the end application?
You basically it's used to it can be used to kind of detect different material, because they will reflect in different ways, and is also you can use it also to check the quality of the signal that comes back. It basically it's not a separate information, but it comes to how much light comes back from the objects you reflect with.
Okay, thank you.
The next question comes from one of the companies that is at the forefront of what I call the micro-optics revolution, SUS Micro-Optics in Switzerland. Neuchâtel, Wilfred, what's on your mind?
Hello, can you hear me?
Loud and clear.
So you mentioned that you need micro-optics. So for which part do you need micro-optics? For the illumination or for the detection or for collimation? So SUS Micro-Optics, we're making micro-optics for automotive already. It's about half of our business. So it would be very interesting to know what exactly you need for micro-optics in your system.
Yeah, for example, we do need some isolator for the lasing. So the emission part there, we need some components for a micro bench. But yeah, I'm really looking forward to take this discussion also with our technical guys. They will probably give you more information than me.
Okay, no problem.
Wilfred, I just heard that the Photonic Leap project was approved. My friend Sylvester from PITC told me. So I'm really excited, about this. You're going to do wafer level packaging of photonic integrated circuits with the micro optics of SUS Micro Optics. I want to hear more. We have an event on co-packaging very soon. I really want to hear more about this. This is really huge for us. I want to go to the next question. We go to the people who invented silicon photonics. Many people know this. University of Southampton, ORC. My friend Milan Milosevic. Happy New Year, Milan. What's on your mind?
Happy New Year, Jose, and thank you, Davide, for a very interesting talk. So, Benny already asked you a few questions about technology, and what I was actually thinking is, in terms of silicon photonics that is currently used for LIDARs, what do you think is the most urgent improvement that can be added to your platform to make it more advanced? Is it the beam steering elements, or
Yeah, I think so. Everything is quite important for beam steering. I think we have a nice and good solution. What we are really looking forward is for amplification of light. If you can think or come up with an amplifier, that will be really a key block. If you can also integrate this, that will be really a leap step in the development.
Two more questions for you.
Okay,
the first one comes from Den Slide. Soma, my friend Soma. Happy New Year. What's on your mind?
Hey, Happy New Year, everyone. Yeah, thanks for that. David, I just had a curious question. People I talked to always said that FMCW requires a lot less power. So why do you, compared to, say, time of flight? So I'm curious to know why you need a 2 to 4 watt SOAs.
I think it depends on the overall system, but the intention here is to use just one laser. And therefore we leverage the presence of an amplifier.
Okay, thank you.
The last question for you is in YouTube, comes from Caleste. My friend Jan Vermeeren is wondering, is an output power of 2 to 4 watts safe?
Yeah, it's not just so eye safety is as said a complex topic. It's not just the power itself, is the wavelength you use, and 1550 from this point of view is giving you some advantage, but it's also how you do the beam steering, and in the end is how much time you stop on a single point with the light. So it's not just the power itself. It depends also on the speed of scanning and so on.
And let's go now to Eindhoven Rock City. Sylvester Lakowski from PITC TU Eindhoven JEPIX. What's on your mind?
Well, I've quickly typed in the question to Davide, and thank you for the presentation. Is a qualification for automotive market a concern for the solution that you're proposing? You know, of course, I see many companies chasing a solid state LIDAR that would be cost efficient, and all flavors of integrated photonics being pushed into, well, there are of course lots of technological challenges to make it happen, but there is somewhere in the background of many heads, will my product qualify for automotive, and how long does it take to get there?
Yeah, it's definitely a critical question. But if you ask if this is a concern, I would say we're doing the thing so that it won't turn into a concern. But it's definitely something more relevant. Yes.
Davide, I just want to say something to you. Scantinel has attracted a lot of interest from the industry. It is really great that with the technology developments that we have done over the last 2 decades, you manage in almost no time to convince everybody about FMCW LIDAR with photonic integrated circuits. You are an example, and I'm really proud of having you on EPIC. Grazie mille. Thank you, Davide. I want to move
that can go only if you collaborate, and that's the key message from my side. You can get this fast only if we collaborate.
And you are doing it very well. After the last meeting, I made 10 introductions. You followed up with all of them. I think I'm going to make the same amount or more after this. And now it's a big day for EPIC, because one company that actually attracted the interest of major players over the last few years is here today looking for cooperations. I'm going to go to Canada. I'm going to go to Xanadu. Xanadu is one of these companies we all want to know more about. Thank you very much, Blair, for being with us today. It is 3:51 in the Netherlands. What time is it over there?
Thanks, Jose. It's 10 in the morning.
Good morning and Happy New Year. The floor and the attention of everyone goes to Canada, goes to Xanadu.
Thanks. I'll share my screen.
When he shares the screen, I would like to thank iPronix. They are the ones who made this possible. So thank you very much. Muchísimas gracias for making this possible.
Sorry, I just had to reboot my computer when Zoom crashed before.
All right, but we'll manage to make it.
Okay,
they managed to program photonic integrated circuits, and they managed to convince the quantum community for investing on that. They can start soon. Fantastic, Blair. The floor is yours.
Thanks, Jose. So thanks for the kind introduction. So I'm Blair Morrison. So I lead the integration team in Xanadu. It's within the hardware team. So Xanadu is a full stack photonic quantum computing company. We work on both software and hardware. So our software products are kind of centered around our quantum cloud offering, where you can access our current NISQ quantum devices through our cloud system. And for this, we provide a programming package called Strawberry Fields, which is a general package for continuous variable quantum computing. It has a bunch of backends and simulators, and you can also use it for optimizing your circuits and accessing our hardware remotely. We also have another offering called Penny Lane, and this is a hardware agnostic kind of API for programming quantum systems. And what's really interesting is that you can use this package to kind of train quantum systems in the same way that you train a neural network. So you can use this for things like quantum machine learning and differential computing. And it's actually supported by a number of hardware platforms, so not just our own, but also superconducting and ion computing platforms, as well as simulators and orchestrators, including quite recently Amazon Bracket. So in terms of the hardware that we offer, we kind of have two main areas of work. So we have these kind of NISQ near-term devices, and these are, again, available at the moment through our cloud system, primarily based around Gaussian Boltzmann sampling. We're bringing more of these online soon. And we also have kind of work based around developing fault-tolerant quantum computers, which is really pushing the state of the art and the frontier in continuous variable approaches to fault tolerance. So, the mission of Xanadu is to build quantum computers that are useful and available to people everywhere. We've been doing this primarily through our cloud offerings. So at the moment, we have 3 cloud machines available. Again, these are based on silicon nitride systems which generate a Gaussian Poisson sampling. This is a form of kind of near-term NISQ application. And this has really blown up since the last 6 months when we made it publicly available. We've got a lot of users onboarded, and we've had this kind of system in development internally for well over a year now. But really, I think for this discussion, what's quite interesting is our new results on an architecture for fault-tolerant quantum computing. So as much as kind of NIST devices are interesting, really for the killer applications, you require a universal fault-tolerant and error-corrected quantum computer, which can scale up to many kind of thousands and millions of qubits. And we have some recent work kind of providing our architecture for this, which is based around GKP qubits and squeeze states. This is a modification of our current approach. And what you can see on the right is an image showing this kind of 3D cluster state, which is created by a modular system of kind of resources, entanglement system, and detection. So this is really kind of where we're pushing forward and where we think partnerships with extra vendors can definitely be a benefit. So if we look at the kind of key technologies required for this fault-tolerant approach, it really is a modular approach, which is quite interesting compared to some of the other approaches in the industry. And you can kind of divide this into 3 sections, so kind of state synthesis, an entangling network, and also measurement and error correction. And I should add that this GKP approach allows us to perform measurements and error correction with kind of traditional photodiodes at room temperature. So that's a unique benefit from this approach. So here, we're looking to further on development with our current foundry partners, but also with other partners. So, really we're pushing the frontier in kind of low loss components, really optimizing chip coupling, and then a few other kind of key figures of merit, including things like high quantum efficiency integrated photodiodes. So I think, that's what we're really interested in talking with people with today. So yeah, that's it. So thanks, Jose and Anne.
Okay, thank you very much, Blair, for this presentation. So just to summarize, what kind of connections or collaborations are you looking for in our network?
Yeah, so I think we work with a number of European partners and vendors already, but I think in terms of foundries, this kind of new phase we're in is a little bit different. So at the moment, we're discussing already with a few foundries, but it's always good to talk with more possible partners there. And I'd say one thing is, really scaling up the packaging. So, the current packaging approaches we have are reasonable, but, we're going to be pushing this up to higher levels. Probably, still not very large scale, but really loss is a key approach. So internally, we're doing research into some kind of initial prototypes, which can maybe fit the kinds of packaging that we need, and we're hopefully going to be partnering with some external partners to make that more scalable.
It is great because we have plenty of companies working on packaging. We also participate in the PICs pilot line that is working with the standards and going to large volumes. So yes, there is a lot of room for collaboration. And now we have some questions here in the chat. So yes, Karen, hello, how are you doing? Happy New Year, Karen, from Lightwave Logic. Do you want to make your question?
Yeah, thank you for the very interesting talk. I might have missed this. You just glanced on it in passing, but you mentioned something about how of your 2 software platforms, one of them enabled some optimization of the hardware, and the other one was what you used for the neural net training. So what kind of optimization of hardware did you have in mind? Obviously, it's not the neural net training.
Yeah, so I'd say that it kind of touches in 2 areas. So, Strawberry Fields is this package that we first developed, and that was really to, provide an interface for continuous variable simulation and also kind of instrumentation with our hardware. So if you look at what most of the work has been done so far, it's mostly around discrete variable systems, so things like QTIP It's more focused on single photons. So our team had to kind of develop this package, and immediately from the start, I think the team was very proactive about thinking about how to kind of push extra benefits from machine learning into these systems. So the Strawberry Field kind of interface has a backend, in TensorFlow, I believe it is, for doing optimization of circuits. So for instance, you can say, have a target quantum state you want to reach, and then you can use that to optimize the linear network and the sources to generate that state. And play around with things like probabilities, fidelities, stuff like this. But I'd say that kind of that interface also does plug into this Penny Lane API. So the thing about Penny Lane is that you can just describe an arbitrary kind of circuit, and then for any number of backends, you can just say, what hardware you want to deploy this on, or what simulator you want to deploy this on, and you don't really need to rewrite that interface. And that interface is a little bit more general, so you can use it for really kind of hybrid classical quantum optimization. So you can take gradients and things like this.
Thank you.
Thank you very much. And now, Marcel from Keysight, do you want to make your testing question by yourself?
Yeah, sure, why not? Hi, Blair. So I was wondering, when you test your quantum photonic chips and hardware, what are the key challenges? Is there any need for new test instruments, new test solutions?
Yeah, so I think, we have kind of two regimes. So we have the typical kind of sweat test style kind of measurements of the classical devices. So definitely from a lot of, I'd say, more traditional kind of characterization methods, you can get enough information to determine whether or not you've had a failure or an issue with the device. On the quantum side, it's definitely something which is a bit more unique. We have a few test beds in the lab which we developed from scratch to do for these kinds of things, but it's not that typical. So, for instance, we have some devices which work at cryogenic temperatures, and we're looking at things like wafer scale probers for those cryogenic devices. But otherwise, most of the testing kind of fits within a typical PIC testing regime.
Okay.
Thank you very much. One question more from Douglas from PhotonPad. Would you like to make the question by yourself?
Sure. Hi, Blair. Nice to meet you. I have a quick question just about, you've mentioned the phase response of the modulators. I mean, this is directly related to the design and operation of the modulator. Are you actively designing these components, or you are outsourcing that? How is it? How is Xanadu moving in this direction?
Yeah, so we're a fabless company, so we definitely do a lot of design. I'd say that's really a requirement due to our extremely stringent loss requirements. I think the typical kind of components available in foundries just aren't really low loss enough for what we do. So that's kind of got us to the point we are right now, and definitely doing development with foundry partners as well to push the requirements. I think for actives, it's going to be a new range of optimization, probably going to require some material science, because definitely there's lots of trade-offs when it comes to these things. And I think, depending on how difficult things are, we could imagine, tolerating some dynamic losses in the system. It depends exactly on what the final implementation looks like. But ideally, a pure phase response is probably preferable.
Okay, thank you very much. And let's keep talking about software, because maybe this is a good moment to introduce to you a company that maybe you already know, Luceda. So who is here from Luceda? Sorry. Maybe would you like to explain what is Luceda doing? Maybe do you have a slide to show?
Hello.
Hello.
This is Pierre from Luceda Photonics. Hold on. Okay, I will share my screen. Wait. No, share screen. Go. All right. Can you share my screen? Can you see my screen?
Yes, we can see it.
Yes. Well, first of all, I'd like to thank you all at EPIC for organizing this high-spirited meeting. It's certainly gets all our hopes up looking into 2021. So I really appreciate all the faces on my screen. It's almost the same as in real life. So that cheers me up already. So to introduce our company, we are called Luceda Photonics, and we are integrated photonic design software company. So LUS stands for light, EDA stands for the connotation to electronic design automation tools. So we want to be the EDA tool for photonics. So how do we approach this market? Well, we have one main platform, which is called the PICs Photonics Design Platform, and it is based on Python. So it can touch all the different aspects of integrated photonics design, which is the photonics layout, the simulation, both at the component level and the circuit level, and then finally the characterization. We are really embedded within the ecosystem, and a lot of the people in here are either our partner or customers even. And so what we do is we support a wide number of foundry partners, across all different material systems. And we also offer integrations with third-party simulation software, such as ANSYS Numerical, CST, and VPI. So what we really see as our added value is that we bring together in one platform all the different aspects of integrated photonics design in a controllable way from Python. And that has two main benefits for our customers. One, it allows them to organize their thoughts and their integrated photonics IP into something that they can version control and that they can know the history of. So typically this is very hard to do if your knowledge is scattered across different people and different software packages. So this vertical integration of photonics IP is something where we add a lot of value. And also this offers the opportunity for our customers and for us to offer design packages that go from component layout all the way to circuits. So to make very complicated things, because everything is centralized in one Python library. So you can provide automation across all levels from component all the way to circuits. So if you have large circuits, such as in LIDAR, for instance, where you have a lot of different light paths that need to be just as long. So this programmatic control over all these aspects is something that's very attractive. Also in quantum computing, I think these things are of high benefit. So that's a perfect meeting for us to be sponsoring. I think my minute's over. Again, I want to thank all the panelists and also Epic.
Yeah, I was a user of IPKIS, and I had to say that what made IPKIS really the platform of choice for many designers is that is the support that we get. And for this, I would like to thank you, Pierre, and to thank all the rest of the team, Peter also, of course, for what you are doing for the industry, constantly supporting the industry. I have something to ask our friend from Xanadu, Blair. You were talking about low-loss photonic integrated circuits, and you also were talking about low-loss packaging, especially fiber-to-chip coupling. I don't know if it's public, but I saw that there is a publication that you have with a silicon nitride foundry, Ligentech, which by the way is in the room. So one of the materials that you are considering is at least silicon nitride. What kind of challenges would you have for the companies who supply packaging of silicon nitride chips? Because you're talking about low loss. Could you tell us amount of fibers that you can put into, that you want to put into a silicon nitride chip, or maybe the pitch, or maybe just the losses, the kind of is 1 dB enough, or you need to go below that? Can you give us a bit more meat on this?
Yeah, sure. So I think for our current devices that we have deployed at the moment, we're in the kind of tens of fiber range, and we achieve coupling losses around kind of 1.5, 1 dB. For these next platform devices, we're talking more like 0.2, 0.1 dB. So we kind of really need to eliminate the coupling interface as a main loss bottleneck, and definitely that's going to be extremely difficult to achieve with typical high index contrast platforms and ultra high NA fibers and things like this. So we do expect we'll have to make some quite different advancements to the coupling interface to achieve that. And that's something which I guess we're looking forward to doing.
So the challenge is on the table, tens of fiber arrays. He wants 0.1 to 0.2 dB losses. You're 1 week after Santa Claus, maybe a bit late, but I think people can actually come back to you on this. Blair, there is a question for you from Heiko from Continental. Heiko, what's on your mind?
Hi, Blair. Your talk just opened a whole bunch of ideas in my brain. So you mentioned that your quantum computing has many similarities with a neural network architecture, and it can be trained in a similar way to a neural network. We use tons of neural networks in our object detection, both in the radar, both camera and LIDAR, and in particular in camera. It's used to a great extent. So in camera, you collect photons, then you have to make electrons out of it, and then you have slow electronic processing. How long does it take until we can see an all optical camera that receives photons and then does object detection, CNN like architecture, all optical?
Yeah, I think optical computing is maybe a little bit beyond the focus of our company, but I'd say that quantum sensing is something we talk about. But I'd say for the systems we have at the moment, the detection part is more like typical, even like LIDAR approaches. So some of our detectors are similar to kind of SPADs and single photon detectors, and then we also do use other systems with more like heterodyne detection that you'd have in, say, frequency modulated coherent systems. So we look at both, but I think the issue with photonic kind of quantum computing is that single photon interactions are very difficult.
I know.
You normally rely on.
And it was a bold idea, but
so we rely on a measurement-based interactions. So
all right, but that's what it is, a measurement-based interaction, just with many channels. Thank you.
Okay, so thank you very much for your comments. And now to finalize with this presentation, we have here an important end user in the optical communication scene. So Vincent from Facebook. Well, first of all, thank you very much, because I think it's very early for you, really early for you. Would you like to comment about the role of photonic integrated circuits in the optical communication scene, or also for these applications like quantum computing?
Yeah, thank you very much to having me. And yeah, it's very early, and I'm sorry I kind of late for this very fantastic talks. The quantum computing is really the power. If I'm looking at our real application, when especially some of the AI and the machine learning is kicking into our infrastructure. So there's several challenges we're having. One is the computing power. Second one is the power density for the infrastructure. So this is the two things we're looking. I have not diving into how the quantum computing can help those two areas. But I think my understanding is that quantum computing will give you a lot of power for potential computing, especially it's going to be help us to doing the machine learning or the AI application. I hope that is the case, but I'm not sure. Back to reality, I think I have some question, to Blair about the coupling loss, and I think that is one of the things that we've been trying to address. Exactly. Especially when you're moving to more and more integrated to the optics, and then the coupling loss from chip to the fiber is going to be common challenges for the platform. As I mentioned, the power of the power density. I think if you can driving the coupling loss down, and the benefit you can have the low power density, as well as the electric, the power, because you can reduce your power or the laser power. So second question I have for David, is that he's talking about several junction of the laser for LIDAR. I think that is a brilliant idea. But again, I think someone has been asked the question about the reliability. I think that is still same remain. When you have a different, like the different junction, especially when you integrate it with photonics, and then how you can quantify for each a combination or a configuration. And the second one, obviously, is safety. And my safety for me is two things. One is about the reliability of your laser. So I think someone has been asking about the reliability of your laser. And the second one is about the failure rate. In the real application, if your sensor is a fail while you are driving, what happens? So that is the two things I was trying to ask him. So I'm sorry to late, but I jumped in too many things to hear. So.
Don't worry. So then you have two questions. One question for Blair about about how they are going to integrate with high density, about packaging. What do you think, Blair?
Yeah, so I think with this kind of new approach we're talking about, one benefit is it really is quite modular. So if you look at the current chips that we have, you have this issue where as you scale them in size, you have a very large increase in the size of the kind of reconfigurable network that's required. And definitely with power density, that becomes a problem. So you can get around this a little bit with things like bump bonding and 2D electrical I/O, but for these fault-tolerant platforms we're talking about, the design approach is a little bit different. So we envision that the kind of electrical density there isn't as problematic, and that's kind of one benefit to this. So we're really going to have many devices, some of them packaged at wafer scale, hopefully, but kind of many sets of kind of wafer scale packaged devices and connected with optical fiber. And then by doing that, we can kind of make it more like a typical chiplet-like approach. We don't have to have a single device with very high yields. We can have many kind of smaller devices. So that's the kind of main approach there. And that also makes the packaging a bit easier. If there's some devices which don't really hit the yield, you can just choose not to use them. So.
Okay, thank you. And then, Vincent, your second question was for Davide from Scantinel about reliability, right?
Yeah.
Davide, what do you think? It's a challenge.
For David, not for
me. I think it was for this David. Yeah. No, that's good. It was my discussion about the multi-junction pixels. Yeah, that's okay. If you don't mind. Look, Vincent, as you know, we've been walking up this path towards higher and higher numbers of junctions. And, there's a lot of challenges in making sure that as you put more and more current through it, that you're reliable. But these are things that we deal with on the device and epi side and process side. So they're all things that are built into the laser technology before they even get out to the point where they even get tested and out to the field. Field failure is super critical. To date, it's a little bit different than your field, right? Your field, in terms of telecommunications, the fit rates have to be extremely low, and lifetimes are extremely long. In the mobile communications space, it's a much different requirement between mobile communications or mobile. The mobile application space, I guess that's most of the 3D sensing exists today, as well as the LIDAR space. There's many different requirements for the reliability there that we address as they come along. And to us, the big challenge we have right now is the qualification for automotive, and that's a really super critical spec. And the way it's done, it's new in the industry. So this is something that I think we've embraced. We've really worked hard to make sure that it works, and that's going to benefit us across the board in the way we do and develop our new products. And we've done a lot of that work already, and it's hard. Not many people can do it, but it's really benefiting all of the other products, and it's getting built-in reliability for the mobile products as well as for the the datacom and telecom products as well.
Thank you, Dave.
Okay, so thank you very much for your comments. And now to really finalize with this presentation, we have, I think that very linked to the comments, to the comment from Heiko from Continental, we have here a company that will talk about neural networks. So maybe Chris from VPI, would you like to explain what your oh, and you have a slide. Perfect. Thank you.
Yeah, I have one slide. Yeah, thank you, Anna. Yeah, this is, you know, I wanted to bring this up in response to one of Heiko's comments. I just wanted to introduce one of the projects that we're working on at VPIphotonics. So what we want to do is help you define the cutting edge. So we get involved in some of these industry leading research projects. This one that we're in progress is called Plasmoniac. It might be interesting for you to look into that. But we're always trying to add new functionalities and applications into our photonic design automation software. So we participate in these projects. And this one in particular, it leverages the energy and size efficiency of plasmonic circuits and applies that to the neuromorphic computing architectures. So at VPI, we're developing an add-on model library for plasmonic devices, so they can be used in conjunction with our photonic integrated circuit models, and allowing our users to build and simulate neuromorphic circuits and evaluate the performance. So I'll just mention some of the early work that has come out of this, was presented last year at Photonics West from the Aristotle University of Thessaloniki in Greece, where they actually used our software to validate one of their architecture concepts. So for Heiko, you know, you might be interested in learning more about this project.
Yeah, thanks for sharing. I guess we will connect after this.
Yeah.
Okay,
yeah, thank you, Anna.
Thank you very much for all this round of discussion. So now let's move to the next presentation. Let's completely change the topic. Let's go for agriculture. So Vincent Dupre from One Planet, would you like to share your screen?
Yes, thanks, Anna. Thank you so much for inviting me on this epic webinar, and I will share my screen. No.
Good. Now you can go to.
Yes. So yeah, so something completely different. So for me, this is a very interesting show to watch always. The epic webinars, but yeah, myself, I'm coming from the agricultural industry, and I have something very exciting to share with you as well. And that is the collaboration of IMEC with two other important partners, and we've founded the One Planet Research Center. So, yeah, for many of those present today, I think IMEC is a known research center in the semiconductor industry. And we have this really exciting collaboration now with Wageningen University and Radboud University and Medical Center. And they are probably, yeah, for those people that are in the agricultural sector or in the health, they are, yeah, probably similar sort of credentials as IMEC has in their own industries. With Wageningen being a leading university in the agricultural field, and Radboud University and Medical Center, yeah, leading world leader in medical research and artificial intelligence. And all these partners come together now in One Planet Research Center to do research on topics that touches application domains of agriculture and health. So we've been really busy. We've been starting 1 year ago now, May last year. Well, May 2019 actually, so more than a year ago, and yeah, and we've been drafting the following research programs where where I would really like to invite people as well to join. So our focus is on nutrition and health, and on the agri-food and environment sides, and within these two broad topics, we've
we've sketched these topics that we're working on. We're really working on emerging technologies that can flow into these application domains with the help, of course, of these university partners that are in the research center. And with One Planet Research Center, we don't only have this commitment of these partners, but we also have a brand new office and facilities where we're actually going to bring all these technologies and towards these fields. So there is already a big team, multidisciplinary team working on these different topics and doing research in these fields to actually validate and test all technology for these applications. So just as an example, we're bringing into the field emerging technologies, and it can be on sensing. This can be from really high to really low TRL levels, and we're bringing this all into validation platforms, being digital or real platforms. And this is quite a fascinating step, actually, where we on the one hand side create validation labs with application partners or with actual end users. So this brings technology really into the market, really close to the actual application, to the actual industries, by having the key players in the industry working with us in real life settings. So sort of digital, also sort of field labs, you could say. And on the other side, with this knowledge we have on how these industries work. I mean, this is years of knowledge from the partners that are in One Planet Research. We actually also formulate digital models of these change and systems and processes. And here we can, of course, create new opportunities to test technology before it even gets into the field. And just to, I'm just going to sneak in a few slides as well of one of my colleagues who is in this meeting today as well. I mean, Avasi, who's happy to explain as well some exciting work that's being done at IMEC at the moment and the silicon nitride photonics. But of course, this is also touching different different use cases and partly also life sciences and health. And the same for the optical beam forming. So if you have any questions on these, then you can shout out to Avasi. But for me, this is about the exciting part of getting all these new technologies that are being developed at IMEC, but also technologies from third parties into these new use cases, into these new settings. And we do this together with a whole ecosystem of key supply chain partners. And this is in that way also a shout out to those supply chain partners, be it either on technology side, application partners, but also closer to the industry in the retail or in the producers actually of food or industrial equipments. And for those partners, we offer a whole range of validation facilities, IP licenses, or and of course the broad industry insights. And it's really an institute. One Planet is really an institute that can help you get technology into these markets, into these agriculture, food, and health domains. And that's actually where I want to leave my short presentation. I want to leave some space for your ideas and suggestions. So
Thank you very much, Vincent, for a great presentation. I also, I live in the Netherlands, and in the Netherlands, we have seen many companies in the agri-food sector reaching out to One Planet to set up R&D cooperation. So it's a success story already, and many bigger things are about to happen. This is a Photonic Integrated Circuit forum. So companies here are developing indium phosphide, silicon nitride, silicon photonics, you name it, and also the packaging solutions for that. Is there, do you have at least one example or one thing that you have seen happening with this technology in the agri-food sector?
Yeah, probably the most exciting one, of course. Well, coming from agriculture, this is very technological for me. Yeah, but for us, the best touching cases here where we can actually, for example, look with hyperspectral imaging or other forms of imaging where we can actually get new other information from by looking at a plant with those kind of technologies. So by sensing with other technologies, we can get new insights, and they're really needed in the industry. We see new ways of farming, and we see new ways of new needs of measuring things to get better and more accurate compositions of what we're growing or what we're sensing.
Vincent, we had already a meeting on agriculture that was fantastic. You remember that we actually have a person in a greenhouse showing us the different sensors that we have already implemented. I think there is always room for collaboration for especially the spectroscopy analysis that we need in the agri-food sector. But one company that already spotted some room for cooperation is also in the Netherlands. That's Lyonics. Paul van Dijk, goedemiddag, and Beste Vincent, what's on your mind for collaborating with One Planet?
And everybody, happy new year for you also. Yes, well, I kind of found out indeed, Vincent, on the existence of One Planet starting 1 year ago, and with your colleague Amina Besi, we have already a project on beamforming, but then not for agriculture, but for synthetic aperture radar. So here you see that different technologies can have or will have maybe the same type of a platform or can use the same type of solutions for other applications. So we are looking forward to work with you and learn about your applications, also both on beamforming and also on our track record with 20 years. This year, we celebrate the anniversary of Lyonics. It started as Lion Photonics and then Lyonics and now Lyonics International with 20 years of experience in silicon nitride. So everybody that wants to reach out to the next level of challenges in silicon nitride, please contact us.
Paul, you have been one of the key people on bringing integrated photonics to new applications anywhere in the world and outside the world in satellite communication. You are mentioning beamforming, and you represent here a silicon nitride manufacturing center all the way to actually provide full products. What is the secret doing beamforming with silicon nitride? Could you summarize this for the end users in the room?
Well, the end users, I think today already talked about it. If I look at the LIDAR, the ultra low loss that you need on the platform that we can serve with our waveguides, also the very compact thing, and then also the amount of switches you have, and then eventually you need to interface it to the fiber, which was another topic. And for that you need to have a kind of taper junction on your platform to feed the same mode profile of the waveguide to the mode profile of the fiber, and that is an art in itself. And our sister company PHIX Photonics Assembly, who was also mentioned and is a sponsor of today, is trying to automate that and bring that to a high quality. You got the coffee mug there. To a high volume, low cost automated assembly. So yes.
One more thing, Paul, before I let you go. You talk about beamforming, but one big thing that I have seen also in the photonic integrated circuit community is beam steering. One thing that Lyonics has been trying to collaborate with many other companies is doing beam steering with no moving parts. What is the current state, and are you looking for potential collaborations on this?
Yeah, so beam steering you can have so using pixel arrays or using phase arrays or using transfer to the RF domain for phase array antennas. So there's also multiple brands of beam steering and beam shaping, and we are actually looking indeed. We made some progress in that, but also looking at high frequencies for 5G, 6G networks at
at 28 gigahertz and 60 gigahertz. So that's in the RF domain, but also in the LIDAR domain. We are working on a new project, Ophelia, and making new time-of-flight based sources and also FMCW sources, which started January 1st of this year together with the University of Twente, with Sonia Garcia Blanco, amongst others. So yes, there's a lot to do there.
Thank you, Paul. And we have another question coming all the way from Southampton. Milan, what's on your mind?
Hello, Vincent, and thank you very much for your talk. It's really, really interesting. So one planet offers many paths to market. I think this area for agri-photonics is very, very interesting. So you could do a lot of things, I don't know, from UV water treatments, from some, imaging, monitoring, and so on, of plants and soil and so on. So what do you see as the most important product, or what are the most important products for your company in the next 10 to 15, 20 years, maybe?
Well, thanks for an excellent question, Milan. I think it's very, it's an excellent question. I mean, for us, this is not so necessarily what's going to be our best product, because I think, of course, we're looking for this collaboration also with third parties that want to trial that technology in these fields, but the demand is actually for getting to know better what's really happening in and around the plant. So the most interesting, on the agri-food, which is my side of the business, of course, on the health side is different. But on agri-food, I would say, if we're starting to look inside the soil, inside of the nutrient contents, for example, what's actually being fed to the plant, which is in a high matter also deciding what the plant can then deliver. I think that's probably the most interesting products being developed there. But of course, this is a new field. So, but by doing this research that we're doing now, we're actually going to open this up, and it might actually surprise all of us what the next product is going to be.
Thank you very much, Vincent.
Thank you very much, Vincent. Thank you.
In this meeting, we talk about 3D sensing already with Lumentum, FMCW LIDAR with Scantinel, quantum computing with Xanadu, agri-food with One Planet. Let's go to the final application field of the day. Let's go to fiber sensing, from structural health monitoring to medical, optics 11 fast technology. Thank you very much, everyone, for being with us today. The last presenter in the room, the floor and the attention of everyone goes to Amsterdam, goes to you. The floor is yours.
Thank you, Jose. Thank you, EPIC, for inviting us to this presentation. And first, I'd like to say Happy New Year to everyone. So I guess I share my screen here. If you see it, let me know.
Yes, crystal clear.
Great. Yeah, so my name is Ibrahim. I'm an R&D manager at Optics 11. So I'm based in Dublin. The Optics 11 FAS is a Dublin division. So giving you a background of what we do, what we are, and how PIC is related to our applications. So the first slide here, let me press. So it's Optics 11. So Optics 11 is an Amsterdam-based company that offers high-end optical sensing systems for various type of applications. And we are focused on two divisions. One is industrial applications and one is on life sciences. And Optics 11 FAS is a Dublin-based company, which is formerly FAS Technology and currently part of Optics 11 since December 2019. Our main focus is on developing high-end tunable laser-based FPG interrogators for optical sensing systems. What are our unique technology or features? What we can offer is we have the world high-end optical acoustic emission system called Optime, where we can sample up to megahertz rates. We have high accuracy and high precision FPG interrogators, which is the i4 interrogator with kilohertz rates. We have a broad portfolio of sensors, FabiPro and FPG-based, for measuring temperature, strain, acceleration, and pressure, and also broad experience in industrial application and life science. So all going from the design of the systems to the end applications. And we have also been looking at developing next generation or future generation PIC interrogators. And the main reason is to reduce low costs and address high volume applications. And the main thing, we want to maintain the performance. So it's not just the low cost, we want a high-end, high volume, low cost system. This slide shows you an example of our interrogation system. So the box here is our interrogator, our currently
which is based on discrete components. And you can imagine it's like a telecom system. It has a transmitter and a receiver. So we have a tunable laser source where we emit the light, and we have a receiver where we measure reflection from our FPG sensors. And the FPG sensors, we can measure, package them into transducer where you can measure strain, temperature, pressure, etc. One of the key features we have is that we can measure kilohertz rates up to 120 sensors. We have very high accuracy in our wavelengths, down to less than a picometer. And we have high precision and high repeatability, down to the femtometer range. The current laser we use in our system is a telecom-based laser. And we use also polarization control to control the polarization. And we can imagine the system as a high-speed spectrum analyzer. So we can measure the spectrum at a high speed, up to 16 hertz and even higher, with 1 picometer resolution. And we also use this feature as a way to measure characteristics of a PIC that we develop or anyone else could develop. What we have been doing on PIC development over the past couple of years, so back in 2013, around that time frame, we were involved in the EU project called Paradigm, based on MPW runs for near phosphide PICs. You can see on the left, this is our discrete optical assembly. You can see a lot of fibers, a lot of splices, a lot of optical components. And the goal was to shrink it, make it smaller, make it more reliable, make it low cost, and also compatible for volume manufacturing. And you can see here, this is back in 2017, we published at Photonics West one of the first designs we had for an interrogator chip based on the receiver side of the interrogator. Currently, we are involved in the DTIF project, which is a national funded project from Enterprise Island, and based on the package from PICSAP as well, where we work with partners like Tyndall and also Embryonics and Phycontech. The goal of this project is to design or let's say decide on the processes to do volume manufacturing of packages. So the idea is to reduce the cost of packaging of photonic integrated circuits. And this is a challenge that we've seen over the past years. It's still low volume, it's still not standard. We need to bring the cost of packaging down. And the main difference in this design, where we have been developing as well with support of VLC, is it has a laser as well. So this design is a transmitter and receiver, including one chip. So touching some of the applications we look at in terms of fiber sensing. So where can we use this technology? So SHM, like for bridge monitoring, where you want to monitor the structure and how it performs over its lifetime. Acoustic emission and partial discharge measurements. Structural health monitoring, like in caves, where you want to see any change in the same displacement over long term, like you don't want to have it collapse on someone. So you keep those in system. And in the term in SHM in general, there's a lot of infrastructures out there that's been old over 50, 100 years. And in order to either you have to go and fix the bridge or replace it, or you want to at least detect if something happens before it happens, so you can basically fix it. Other applications, road monitoring, where you can install fiber bar grading an array into the road, and you can detect traffic, monitoring speed, without even affecting the, let's say, the road itself, without even, it's not even visible. So it could also be used for weight measurements. So these are new emerging technologies and applications where it takes advantage of fiber sensing, and then fiber sensing also takes advantage of photonic integrated circuits. And as I said, for low cost, high volume. Some other applications we have here is for wind turbines, foundations and wind turbines monitoring. And also on the life science side, this is one recently has been interesting, is organ in the chip, where you have like an array of samples really to measure the mechanical properties of organoids or cells or tissues. And you need to do it in a parallel way, where instead of having one sample, you want to go up to 24, 92 samples and simultaneously. In order to support that, you also need to have the platform and also the measurement system that could integrate all those samples at the same time. And you can imagine each sample is like a FabiPro sensor cavity, and you need to multiplex them at high speed. So that's the main slide. So the last slide here is questions. So what can we offer? We can offer high performance sensing systems for industrial application, SHM, and for life science. We also have a system that could be used for rapid characterization of packaged PICs, where you can measure at 16 hertz, a full spectrum in C-band with 1 picometer resolution. And we're also planning to use this for our own PIC. So it's like a feedback. We design the PIC that could design this test itself. And also we have experience in challenging real-world applications in SHM and industrial life science. What are we interested in? We currently use fast tunable lasers based on telecom technology, like STDBRs and MGI. And we would be interested to, if anybody in the group here have developed or have in the roadmap to develop a high-speed tunable laser that cover the CNL band. And the same laser are also used for OCT applications, telecom and LIDAR, so there could be some overlap there. We are interested in any application where high volume, high performance interfaces are required, where we can help. And also what's interesting is the standardization of PIC packaging and testing, because at the moment it is a major cost of the PIC is the testing and the packaging of such thing. And enable high volume production at low cost, you need to introduce standards. So if everybody can, I think the whole community will benefit from that. And I guess that's the last slide I have. So thank you. Thank you very much, Selvan, for this presentation. And well, you already said what are you interested in. So maybe now I can make a couple of introductions for you because we have here Expo. Francois from Expo. Yeah. You offer some kind of testing solutions. Maybe do you have a slide to tell us what your company is doing?
I do.
Very good.
Let me know when you see it.
Yes, we see it.
Okay. So yes, Expo has been involved in test and measurement since 1985, and I would say for the past 5 years we've developed a line of products, particularly for PIC. So we interact a lot with our customers, trying to see what their challenges are in terms of speed, dynamic range, accuracy. And also from the instrument perspective, the integration, having something that's flexible and a certain degree of automation. And what we found is that whatever the application, you can basically split the testing into either the thing is emitting light, so it's an active component, or is guiding, filtering light, so it's a passive component. And what we have is a line, or actually two lines of instruments. The top one is more to do with active component testing, so it's an OSA or even tunable filters. These tunable filters more maybe for quantum computing applications. And the passive component side, we have a passive component, and that is linked to a tunable filter. So I think what Selwan was describing was something maybe closer to an OFDR type of thing. Here we have a component tester that sweeps the wavelengths with a continuously sweepable laser, and we detect on the other end of the device what the loss of the device. Could also test PDL or return loss in that way. The key here is that the device can have multiple outputs, and we can test this with a 1 picometer resolution and plus or minus 5 picometer accuracy. As we can see here with the ring resonator, we can really define very fine events or very fine features spectrally without having to slow down the device, the speed of the scanning. Here we're scanning at 100 nanometers per second with the laser, and we achieve this kind of result in a matter of seconds. So, Selwan, I don't know if that would be something that would be of interest to you, because you said that you are actually designing something that will test itself.
Well, the system we've developed is very similar. So we can also measure the full spectrum. So we get 40,000 points with 1 picometer resolution, with 1 picometer accuracy, but at 16 hertz. So it's less sub-seconds. So I know from the testing, I mean, there's a target. If you are developing volume production and you have thousands of chips, you want to speed up the test. And there's a target down to 5 seconds. If you want to go down to 0.1 second, you need a faster, like 10 hertz will give you that. So what you have is very similar to what we have, but across the C-band. But we're not, at the moment, we're seeing whether is that technology useful for you or other test companies out there who want a system that could, a step laser that can sweep very fast, very accurate. And at sub-seconds, like 0.1 seconds, you get a full spectrum measurements. Is that something useful for bringing the cost of testing down, speeding up the testing and packaging? So it's more like similar to what you do. We haven't really gone into that area, but we have a system that could be used for that. And so we are developing the PIC itself for sensing, but at the same time, we're also trying to use it for testing the PIC. It's more like a feedback loop or chicken and egg. But I'm just saying this technology could be useful for you as well. And I know with the test, we do have a polarized source, so you can also control the polarization. So if you're testing a PIC under test and you have polarization sensitivity, you can control the polarization. So you can see what's the polarization effect. Because this is from our experience, when we test our PICs, it is polarization sensitive. So a depolarized broadband source is not good enough. And at the same time, we have features down to the 10 picometers. So we need 1 picometer resolution. So the development of this test came from our PIC. As you mentioned, ring resonators is a good example where if it's very narrow and you want to characterize it, you need a good test system. So yeah, I understand like your system is more commercial out there. I think what we have is more like an engine that could be used for fast testing if somebody's interested. So thank you very much for your questions and your answers. And then about the packaging, I would like to introduce you one of the companies that is in the room. So Thomas from FineTech, would you like to tell someone what are the services that you offer, well, the technology that you offer for packaging? And maybe do you have one slide as well? Thomas from FineTech. Okay, we can come back to Thomas later. And okay, so to finalize, I would like to introduce you. We have another big end user in the room. So we have Martin from John Deere regarding agriculture applications. Martin, maybe you would like to explain us what is John Deere doing and what are your main interests in photonics. So maybe we can find some collaboration for you in our network.
Yeah, hello everybody. Happy New Year to all of you also from this end here out of Germany. I know I would say John Deere is one of the well-known agricultural machine manufacturers. As you might know, we're not only in the agricultural machine business, but also in the construction forestry.
Sorry, Martin, I think we have some technical problems here, but I'm sure what you are explaining is super interesting, but the sound, it doesn't, try again?
Okay, is this better? I don't have another option here for micro right now.
And if you disconnect the headphones, maybe?
We will try, we will say. I will turn off the...
Is this better?
Yes, much better. Is the same? Yes, sure.
Okay, so John Deere is a manufacturer of agricultural machinery, forestry and construction, as well as road construction machinery. And we just went through a major reconstruction of our organization. And we are working in a concept of the production systems now, and the production systems is, for example, in agriculture, a small grain production system. And here we are considering the complete agricultural technology that's required from the preparation of the soil until the harvesting and transport of the harvest, really. And as Vincent did a great job in explaining on how many different aspects are there, we are working in almost all of them to the one or to the other extent. And that's why it's really exciting. So to see on what you are doing, and what I found over time was that there are so many solutions out there, and we just have to find the right ones in the right area of interest to actually utilize them for our applications. And that's why I liked your presentation very much, Vincent. That was great. And maybe a few words. So we are looking into the analytics of constituents. We do have utilize NIR sensors for constituents in grass silage or corn silage. We do have optical systems for guidance systems that we utilize. We also analyze drone imagery in different wavelengths for the analysis of plant health and growth. And we also use the photonics in the area of recognition of obstacles, but also in the recognition of plant material, for example.
That was Martin Klossman from John Deere. John Deere. John Deere. I'm so happy to organize meetings with end users looking for cooperations at this meeting. Martin, thank you so much for your constant feedback. And thank you very much, all of you. What an amazing meeting. What a way of coming back from the holidays. We had companies looking for partnerships. Lumentum looking for partners with module integrators, detector solutions, and like electronic integration for their big cells in 3D sensing. We had the company that I love in FMCW, LIDAR, Scantinels, looking for micro-optics, packaging of the micro-optics, SOAs from 2 to 4 watts, and even low power 1550 nanometer switches. We have Xanadu, low loss PICs and low loss packaging, and they set a challenge for everyone, 0.1 to 0.2 dBs, fiber array to chip, and we are talking about tens of fibers in the fiber array. Agri-food was represented by One Planet. They are looking for joint R&D cooperation in new sensing technology, especially spectroscopy for the agriculture sector. And we finish with fiber sensing. Optics 11, very clearly, they want a tunable laser with a kilohertz continuous sweep, with a line width of less than 20 megahertz, and that can actually sweep the entire C plus L band. That's clear. And for me, the highlight was that we had more than 100 companies looking for cooperation. Actually, in the Zoom room, during some time, we had more than 100 people here, 1 person per company, looking for cooperation. So just remember, we try to make sure that all the companies who register find room for cooperating with the different companies. I would like to thank you so much for the support. The first ever meeting with 100 people in the Zoom room, that's fantastic. As it is fantastic to continue having the support of all of you. I live in North Pike, by the sea. There is no snow here, but it's freaking cold. And all I want is to get warmth. And I get the warmth from these fantastic Epic Online technology meetings. It is now already 2021. I can't wait to start traveling. But in the meantime, just make sure that you sign up for all the online meetings. We have 2 per week. On Wednesday, we are dealing with high ultra-fast and high-power lasers. But until then, I would like to also, on behalf of a fantastic team of laser experts, medical experts, photonic integrated circuit experts like Anna, to wish you a fantastic year and to wish you all the best as an EPIC member. 650 EPIC members keep giving us the support. I also have to say, on behalf of Carlos Lee, you are making him a very, very happy man being the CEO of the biggest photonic association on this very planet. Here is the schedule for the Epic Online Technology meetings on Q1. Write down which was important for you and go to the website and register online. And to everyone, if you're gonna get in touch with any of the participants today, send me an email, jose.pozo@epic-asoc.com. I have no life apart from photonics. I love introducing companies and I will do that for you. From North Pike, almost close night. Keep going. Take care. Bye-bye.